let's look at multiplying polynomials. So if we remember, we had something that was called the distributive property. What the distributive property does is it's multiplying a term that's outside of a polynomial. So for example, in this case I have a 2x, and it's outside of a 3x squared minus 4x plus 7, that trinomial. So if we look at the trinomial, we can see that there's no like terms inside. So I can't simplify what's inside the bracket. So instead what we're going to do is we're going to take the monomial outside and we're going to multiply it into the bracket. Okay? So using the distributive property, what that means is I'm going to take that first term and I'm going to multiply it by the first term in the bracket, which is the 3x squared. So 2x times 3x squared, that's going to give me 6x cubed. Okay? And we're going to continue on. The first term outside the bracket then needs to get multiplied by the next term in the bracket. So 2x times negative 4x will give me negative 8x squared. So remember, when we're multiplying the numbers together as well as the variables. Then the last one takes the 2x and it multiplies it by positive 7. That's going to give me a plus 14x. Okay? So this is the distributive property that we've seen in grade 9 as well as in grade 10. But what we're also going to look at is what happens now if I take the 2x and I put it on the right-hand side of the bracket. So instead of having it distribute into the bracket by looking forward, the 2x is now at the end. If we look at multiplication, we can just look at what's happening inside the bracket. If I want to take this 2x and multiply by 7, as long as the term outside gets multiplied to all the terms inside the bracket, it should give me the same answer. Right? So 2x times 7, that's going to give me a positive 14x. If I multiply 2x times negative 4x, that gives me negative 8x squared. And the 2x times 3x squared should give me a positive 6x cubed. If we look at these two, they do look exactly the same. Generally, when we talk about good communication, we like to write our polynomials in descending order. So I'm going to take that polynomial that we just multiplied, and I'm just going to rearrange the terms. So remember that the number has to travel with the sign that's in front. So if I rearrange this, this is positive 6x cubed minus 8x squared plus 14, which is exactly the same as what we had before. The reason that this happens is that multiplication has what's called a commutative property. So what that means is that no matter what order I multiply in, as long as I'm doing the proper number of multiplications, I should get the same answer. So that means if I had any two polynomials, let's call them a and b, if I multiplied a times b, it would give me the exact same answer as if I multiplied b times a. It works similarly with numbers, so if I multiplied 2 times 3, it gives me the same answer as if I multiply 3 times 2, because order with multiplication doesn't matter, as long as the multiplication is still giving me the same result. Okay? So let's extend this a little bit from what we learned last year. Last year I gave you an example similar to this, where I had two binomials and we were multiplying them together. So instead, in this example, what we're going to do is we're going to simplify three binomials being multiplied together. Okay? And again, we're going to do this in two different ways because I have three binomials, I want to see if order is going to make a difference in terms of how we multiply. Okay? So I'm going to write the three binomials again, and we're going to look at the first two before we look at the third one. So the third one I'm going to leave for a minute, and we're just going to look at multiplying x plus 1 times x plus 2. Okay? If you recall from grade 10, we took a distributive property and we extended it. So instead what we're going to do now is we're going to take the x and we're going to multiply it to both terms in the bracket. So I'm going to take x times x and then x times 2. Okay? We then took the second term in the first bracket and multiplied it by both terms in the second bracket. So 1 times x as well as 1 times 2. And that gave us x squared plus 2x plus x plus 2. Those are the four terms from the multiplication. And then the x minus 3 we're going to leave exactly the same way as it was because we haven't touched that yet. We're going to leave that alone. Okay? So for multiplying x plus 1 times x plus 2, we had x squared plus 2x plus x plus 2. And I can see that there's two like terms right in the middle. We're going to add those together. So I have x squared plus 3x plus 2. And the second bracket we're going to leave exactly the same. Okay? So we can see that from the first two binomials being multiplied together, we've ended up with a trinomial, and I still have a binomial that's left over. So, using the same principles of what we did with our first set of binomials, we're going to now multiply these two polynomials together. So in order to do that, we need to make sure that every term in the first bracket is multiplied by every term in the second bracket. So we'll do this one term at a time. The first one we're going to look at is we're going to look at the x squared, so the first term in the first bracket. We need to make sure we multiply that with both terms in the second bracket. So I'm going to take the x squared, I'm going to multiply by the x, that's going to give me x cubed. And I'm going to take the x squared, I'm going to multiply by negative 3, that will give me minus 3x squared. Okay? Now we want to do the same thing with the second term. So the 3x in the middle of the first bracket, and I want to multiply that term by both terms in the second bracket. Okay? So we're going to do that again. So 3x times x, that will give me positive 3x squared. 3x times negative 3 will give me a minus 9x. Okay? So now we've multiplied the first two terms by the second bracket. I have one term left. I'm going to take that positive 2 and I'm going to multiply it by x and by negative 3. So that's going to give me 2 times x, which is plus 2x, and 2 times negative 3 is going to give me minus 6. So we've multiplied 6 different times and I end up with 6 different terms. So the last thing we're going to do, just like we did before with adding and subtracting, is we're going to look at those like terms and we're going to add them together. So luckily these ones are already written for us together. We have 2x squared terms and 2x terms that we'll combine. And I'm going to be left with an x cubed, negative x squared and positive 3x squared. Those are going to cancel, so that's going to give me 0. I don't need to write that. So I'll have an x cubed minus 7x minus 6. Okay, we said we wanted to look at order. So the first time we did this, we multiplied the first two binomials together. This time what I'm going to do is I'm going to take the second two binomials. So I'm going to leave the first one this time, and I'm going to leave it exactly the way it is. We're not going to touch it. And I'm going to multiply the second two binomials together. So same way we did in grade 10, I'm going to take the x times negative 3, and then the 2 times x, and the 2 times negative 3. And we're going to multiply those together. Again, we said the first bracket stays the same, so I have an x plus 1. And then with the multiplication, we'll end up with an x squared minus 3x plus 2x and minus 6. We've been doing this for a while, so if you'd like, you can do this in your head where you have a minus 3x and a plus 2, and we know that that's going to give me a negative x, so we can write it as x plus 1 times x squared minus x minus 6. We can skip that step of the like terms because we know we're going to get a trinomial. If you'd like to do that in your head, you can. If you'd like to write it out, that's also okay. Okay? So if we wrote it out, you're going to simplify, you're going to get this exact same line regardless. And now we're going back to that multiplication of a binomial times a trinomial. Okay? This time my first bracket only has 2 terms, so I have to make sure that both those terms get multiplied by 3 terms in the second bracket. I should still get 6 multiplications the same way we did last time. Because I'm going to take that first term, I'm going to multiply it by x squared, that will give me x cubed. That first term times negative x will give me negative x squared. And the first term times negative 6 will give me negative 6x. We're going to do the same thing with the second term, so that positive 1. I'm going to multiply 1 times x squared, 1 times negative x, 1 times 6, which is exactly the same thing. So I'm going to add x squared minus 6x minus 6 onto the end. Okay? So now, again, we're going to look for like terms. I have a negative x squared and a positive x squared. That's going to make 0. So again, we don't need to write that. Negative 6x and negative x is going to give me negative 7. So I'm left with that same x cubed minus 7x minus 6 that we had the last time when we multiplied in the other order. So if you notice, this is the exact same, which means that order, when we're multiplying these binomials, shouldn't matter. Okay? This is called an associative property. What that means is if I multiply a times b first and then multiply by c, that's the same thing as if I multiply b times c and then multiply by a, where again, a, b, and c can be any type of polynomial. That can be a binomial, trinomial, monomial, or even just with numbers. The same multiplication property applies.